All right, let's take a look at conceptual problem 3.8. I get asked about this one quite a bit, and it's basically asking you to apply the concept of anions and cations in terms of ratio. Their use of the red circle and blue circles here can be a little confusing in this context. They are telling you that your red spheres are cations, meaning that they're going to be the positive ions. They're telling you that your blue spheres are anions, meaning that they're going to be your negatives. Remember that your chemical formula always represents a ratio of these two, and that positive ions are always given first when writing a name or writing a formula. So a formula is always cation followed by anion in terms of writing the name. For example, if we just looked at the lithium bromide over here, lithium is your cation, bromide your anion. So what we have to do is we have to get the ratio of each in the pictures. So if we come up here and we count, let's count our blue spheres in picture 1 first. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got cation 10. Then let's do the same for our anion. Oh, whoops, I got that backwards. Just a second. Blue is our anions. I did not mean to confuse you. Blue is our anions. So we've got anion. Darn it! Anions 10. There we go. Now we're going to do the same thing in counting our cations. 1, 2, 3, 4, and then 5. So we have cations 5. Well, it's an ionic compound. We always write the formula of a chemical compound in lowest terms or lowest ratio. Both can be divided by 5. So we get 1 cation to 2 anions. So we go over here, since part A, they're asking about question 1, which of these could be this? If we look, which is a 1-to-1 ratio? Well, you've got 1 lithium to 1 bromide. So that's a 1-to-2 ratio. 1-to-2 ratio. Good grief. Late in the day here. 1-to-2 ratio. That's a 1-to-1 ratio. That's a 1-to-1 ratio. That's a 1-to-2 ratio. So calcium chloride is 1. This is a 2-to-1 ratio. That's not what we're looking for. This is a 2-to-3 ratio. So that's not what we're looking for. So for part A here, it's only going to be your calcium chloride. Note the compounds are going to be different for every single person in the class. But how you work, it's always going to be the same. And drawing 1 is, every variation I've ever seen is always that 1-to-2 ratio. All right, and then let's take a look at part B. In part B, it's the exact same thing, but here in part B, they're asking you for drawing 2. So we're going to take a look at drawing 2 using these exact same compounds. In drawing 2, if we count our number of reds here, we've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So we've got 10 cations. And then we count our anions, and we have 10. So here we're looking at a 1-to-1 ratio. Who's got a 1-to-1 ratio? Well, there's a 1-to-1 ratio, so that's going to apply to picture 2. That is a 1-to-1 ratio right there, and that's going to apply to drawing 2. This is the one that people dislike and have trouble with. And that has to do with the wording of the pictures. They say that these little blue spheres represent an anion. Well, you've memorized your polyatomic anions. So even though it's a 3-atom anion, in terms of how they've defined this little picture, it only needs one ball to represent it. Traditionally, if you're using a space-filled model, it should have 3 balls, which is one of the problems I kind of have with this problem. But that unit is a polyatomic anion, so it counts as 1 ball, or it's represented by 1 ball. Then you have your positive sodium, that's your other ball. So you do indeed have a 1-to-1 ratio there. And that's the one that really throws people and really bothers people. And those are your 2 answers to that question. And that's it. Beep.